Hello everyone, welcome back to my YouTube channel. I hope you're doing great. And in today's video, we will be going to learn how to containerize our application using Docker, and then we will try to deploy our application using Docker and Docker Compose. This video might be a beginner friendly if you have already worked with Docker, but we will also cover few of the important things like reducing the size of Docker image by having multi-stage Docker files, because while working in the production environment, we used to have the Docker images with minimal layers and minimum common vulnerabilities. So the less you have package in your Docker image, the more it will be secure. So we will be going to follow that thing as well. And the application we are going to deploy is three-tier application where we will have front end, back end, and database. There would be many more things after doing this, like you can enhance this deployment using Kubernetes, and then you might deploy it using Helm charts in multiple environments. So this will give you a picture that how to deploy your applications in multiple environments. But today's I want to make this video beginner friendly and intermediate level of people who don't have enough knowledge about Docker and Docker Compose. So we will be going to cover that thing. So let's get started. So first of all, if I just show you that we have backend and front end, and I was saying that we have a database as well. So I will tell you that okay, how to create the database, and we are not following anything apart from Dockerfile. So it means that I'm going to create each and everything using Dockerfile. Either it can be front end, back end, or database. So let's understand the code first. That I will just give you a small brief. So we have an application that is student portal, and in that student portal, it's just a kind of a data that we are inserting as a teacher or as a student, and in that data we are inserting few subjects name, roll number, and a little bit information, and then we are storing in a dedicated database or dedicated tables. So for that we have backend that I've written in Node.js, and then we have front end that is written in the React.js, and also like we will also talk about the file structure, that is when we will be going to implement things. Now the next thing is that we have database. So for the database we are using MySQL. So it is kind of a mrn application, or you can say MERN application, but in MERN we used to have MERN, but we have just MRN. And in MERN stack, M stands for MongoDB, but we are using MySQL. So again, it's all up to you. And I just want to understand that, okay, I just want you to understand that, okay, how to containerize your application, what are the steps that you need to take care of. So with the help of that, you will be able to understand. And this template will help you to deploy any of the application. Either it can be a Python application, Django application, Java application. The main thing is that we have to understand how to write Docker files, and then how to deploy with Docker Compose if you are not aware. So Docker Compose thing won't take much time, because if you understand Docker file things, then it would be very easy to understand things from Docker Compose as well. So let's start it with database. Right now we don't have database folder. So as I told you that we will be going to configure database from Dockerfile. So yes, we will be going to do that. And for that, we don't need any code, because it just need an image to create the container of MySQL. So that we will do. Let's start writing the first Docker file, which is database. Now, why we are writing the database first? Because the approach we are following is from bottom to top approach, in which we are configuring database, then we will configure our backend, because backend needs database. So that's why we are setting up the database first, then we will set up backend, and in the end we will set up frontend, because frontend needs backend. So that's why we won't get any error while running these Docker files or Docker containers. So yeah, so first I will create the folder which is database, and in that I will create the Docker file. So we have the Docker file. So as we are writing the Docker file for the MySQL. So the first thing that we need to have an image. So for that we will use from, and I will use MySQL image, and currently we will use latest tag. And I will tell you that we should not use latest tag. Most of the time when you're working in a production environment or any non-production environment, I would encourage you to not use latest tag. So I would encourage you to go with a specific version. We are using MySQL latest for now. Then we will be going to set few of the environment variables, because to run a database we need MySQL username and password. So we will be going to use that. So for that I will use environment, which is env. Then we will provide the MySQL root password. Then we will provide the MySQL root password. So it's not a good practice to provide the password from here. Now I'm not covering the secrets management thing here, because we are containerizing our application on our local machine and we are not pushing it anywhere else. So for now it's fine, but when we will be going to work on Kubernetes, so at that moment we can use secrets management. Either you can use HashiCorp Vault or AWS Secrets Manager or parameter stores. So from there you can fetch the root password or any password. Again, it's not ideal to use root password when you're working with an application, because you should have the dedicated username and dedicated database for that particular username. So this is how the approach when you're working in a production environment. For now I will just simply use MySQL 123. It's a very basic password. Then we will use the database. So for that I will just use MySQL underscore database. So for that I will just simply, so the database would be school. Then we have to expose our MySQL container, so backend will be able to connect with the MySQL container. So for that we will use 3600 port, because this is the ideal port for MySQL. Then we have to use the next thing, which is persistent storage. So let's suppose if your container is getting deleted, so in that moment the data will be lost and we don't want to do that. So for that we will use volumes, and with the help of that volumes we will mount that volume on our local machine, so the data will be replicated on our local machine. So if the container is getting deleted, so we will have that data in on our local machine. So whenever the new container will be created, it will use that directory, and from the directory it will replicate the data in their container. So for that I will use volume, and the location I will use, which is where live MySQL. And in the end we will run the container using MySQL d command. So using MySQL d command we will run our container. So now I will just save this file. Now after writing the Docker file for MySQL image, we have to do the next thing, which is, as we have mentioned few things like volumes. So for that we need to create the volume. So after volume there is one more thing, which is network, because we have three different containers, so we want them to communicate with each other. So for that we need to create one network, and in that network we will deploy our all three containers, or all three applications. So with the help of that it won't get any issues. And also it is kind of a network policy you are setting up, where the others network container won't be able to communicate with this network's container. So this is one of the practice that you should know. If you are deploying your application on Kubernetes, you don't have to do that. But so first of all we will be going to create the network. So for that we have a command which is docker network, and I will write create, and I will create the network name with 3-tier network. So as we can see that the Docker network has been created. So let's check the network. So for that we have a command docker network ls, and we can see that we have the network ID and the network has been created, which is as a driver bridge. Now after that we have to create the volume. So let's check the existing volume first. So we can see there is only one volume. So now we will create the volume. So I will keep my volume as MySQL-data. So let's again check the volumes. So we can see that the volume has been created. So these are the prerequisites that we have done. Now we will create the image for MySQL image. So for that I will just write docker build, and I will provide the tag which is MySQL-image. And yeah, before that I have to go to that Docker. I have to go into that database, or we can also provide the Dockerfile from here. And we can see that now we can see that it is started to building the image, and it, as you can see, that secret use in arg or environment, do not use arguments or environment instructions for sensitive data. So it is warning, and again it is expected because we don't have to do that. Now if I check the images, so we can see that we are using the MySQL image with latest. So now we will have to run the container for this MySQL image. So let's run the container of this image. So for that I will just use docker run -it. Then we will run this container in a detach mode. For that I'll use -d argument. Then we will have port. So we will have to provide the port which is, I think the port is 3306, not 3600. So I'll just correct this, and then we will provide the port. So we will have the same port. Then we have to run our Docker container in the same network that we have created. So for that I'll provide the network name which is 3-tier network. After that we have to provide the image. We have to provide the volume as well. So I will provide the volume which is MySQL-data, and then we have to provide the location. So for that the location would be /var lib /MySQL, and in the end we will provide the image name. So for that we have MySQL-image. Now we did not provide the container name, so we will also provide the container name because it's good to provide container name to identify your container. So I'll just write MySQL container. So the command is I've written. Now I'll just hit enter, and we can see that the container has been created. So let's check the container, and as we can see that the container has been created. Now let's check the logs of this container. So we can see that the init process has been completed and it is ready for startup, and the MySQL server has been running. It is running, and there are few things that is saying that SSL for MySQL container that should be enabled. We are not setting up right now. So the container is running. So now we have to build our backend application, and for that we have to create the Dockerfile. So now we will create the Dockerfile for backend. So I'll just create Dockerfile. Now before that I just tell you that when you are working with backend, so we have .env file that used to have, but it is kind of outdated thing that we used to have in 4 or 5 years back. We used to have .env file, but in today's time you don't need .env file because you can get the credentials value from your secrets management services like AWS secrets manager. But for now we are using this because we are doing this on our local machine. So these are the values, passwords, and also container. So you can see that the container name should be correct. That's why I kept the container name as MySQL container. Then after that we have database as school, and the other configurations are correct. Now let's create the Docker file for backend. So I'm using Node.js application. So for that I will use Node.js image, which is, I will go with Node 14. Now if you want to know the current tag or any node images or any specific images tag, you can go to the Docker Hub and search for the particular image and you can get the tag of those image. So we are using node 14. Then I will set up my work directory, that is app. So then the next thing that we have to provide is package.json file. So it's always good to provide the package.json file because it will save your time to build the Docker image in less time. So I will copy all the packages file to that slash app file slash app directory. So I'll just use dot slash. Then after that we will run npm install command to install all the dependencies and all the things that is required, and for that it will create node modules folder. So I will just run npm install. Then we will copy our other configurations files like server.js or .env, whatever it has. Then after that we will expose our Node.js application. So I will expose this on 3500 port, and in the end we will run our application which is server.js. So for that we have a command node and we will run it using server.js. So this is node server.js. We are using this command to run this. Now one more thing, like as you can see that there is a copy, we are copying each and everything, but if you want to exclude particular things, so what you can do, you can use docker.ignore, and this will help you to ignore the particular file. So if you want that, okay, I don't want to include node-modules directory to go there to copy in that container, so you can add that, or any other file that you don't want to copy in the Docker container, so you can use this. So our Docker file is ready. Now we will build the image. So I will write docker build -t. I will provide the image name as backend, and I will provide the folder. So this is the folder, and we can see that the image creation has been started, and it is also completed. So let's see the image first. So we can see the backend image has been created. Now let's run this. Let's run the container of this image. So again I will use -d for detach mode, and the port will be 3500. Then I will use hyphen network. So dear network. Then also we will provide the container name. So I'll write backend container name, and then we will provide the image name. So let's run this, and we can see that the container is started. So I'll just run docker ps, and we can see that the container is started log. Now let's check the logs of this container. So we can see that the connection to MySQL is done, and also it created some tables like student and teacher, and we can see that the server is running on port 3500. So we can check this on our browser itself using by accessing on 3500 port. So let's access this. So if I just hit on my localhost 3500, it's 3500. So we can see that the message is from backend, and we can see that is student data. So by default it's fetching the student data, and that is currently not available. Like there is nothing available in this student data, so it's fine. So now we have to deploy our front-end application. So for that we will go to our front end, and we will create the Dockerfile for front end, and we have like source, and in that we have code. So for that we will be going to use different node version because it's all up to the application's requirement. So for that we will be going to use node 21 image, and this time I will be going to use Alpine image. So if you're not aware of Alpine image, so Alpine image comes with very minimal packages. It saves you a lot of storage while creating the image. So when you are creating the image, you will see the difference, that how much space is taking when you are using native Node.js image or when you are taking Alpine image. So you will see that it is taking less storage as compared to native Node.js image. So for that I'm using Alpine, which is Alpine 3.17. Then again I will set the work directory, that is /app. Then the next thing we will do, we will copy our package JSON. So most of the time when you are deploying a Node.js application and React.js application, so there would be a lot of similarities till package.json, because there would be dependencies. So the types of dependencies will be solved by the similar commands. So we have to copy this, and then after that we can run npm install, and then after that we can copy our entire configurations. The next thing that we have to provide is, you can see there is a React app API base URL. So frontend needs to connect with backend, and for that it needs a URL. So what exactly the URL and what is the port? So it's kind of an address that it needs to connect with that backend container. So for that we are providing that thing, and again you can use states management services for that. So for that we will go with the way where we will use arguments and environments. So for that argument, so while you building the image or running the container, it will take the argument, and whatever the argument you will provide at the runtime, it will take it and then it will build the image according to that. So you don't have to hard code that thing. So while working in the CI/CD, you can use GitHub, you can use credentials, and via credentials you can provide the backend APIs. So I will keep this as and in the env I will keep the same thing, because now after adding, like providing the arguments, we have to set in the environment variable, because you can see that it is getting the value of API base URL from this environment. So that's why we need it. Then after that we have to get this value through the argument. So I'll just use $sign. Then we will build our application using npm run build, and then we will expose the application, and we will be going to expose our application on 3000 port. And in the end we will be going to serve static files using so for that I have one command, and I'm just copying it and pasting it here. So yeah, like already I have these are the Docker files already I've created. I'm just pasting it, because if I explain you the pre-existing Docker file, so I don't think so it makes sense. So that's why I'm just taking, like I'm just writing the Docker file from scratch, so you will be able to understand like why are we doing that thing and what is the purpose of that thing. So whenever an interviewer is asking you to write a Docker file, so you will be able to explain him that why are you doing that. So that is very important, because each and every line has a meaning. Why are you doing that? What is the purpose of it? So yeah, this is the Docker file for our front end. So now we will build the image of for our front end application. So for that I will run command docker build -t, and I will provide the image name is front end. Then after that, as I've told you that we are providing the argument, so for that we have to provide the argument from while building the image. So for that we are using -build -arg, and I will provide the argument from here. Just remove this. When we were accessing our backend application, so you can see that we are accessing on localhost 3500. So we will just simply use localhost 3500, and we can also add the HTTP. Then we will provide the Dockerfile image name. So for that we will provide frontend location. So after that we can see that the image creation has been started, and this time it will take some time because it's a big application. Like it takes like more time as compared to backend, because backend has very limited lines, but in the front end we have a lot of things, so that's why it will take some time. So now we can see that the image creation has been successful, and let's see the image, and we can see that image has been created. Now we will run our front end container. So I will use the command docker-d, then we will provide the name, and for that I will provide the name of container is front end container. Then I will provide the network, which is 3-tier network. Then I will provide the port, which is, so we will access our application on 80, but the port is exposed by front end container is 3000. And then we will provide the image name, which is front end. So now we can see that the front end container is created, and let's check the logs of this container. And we can see that it is saying that following package was not installed, like serve at the rate this, but this is a warning. But you can see that info accepting connection at localhost 3000. But yes, let's try to access our application. So we will just remove this, all these things. Okay, let's keep it as it is. Now let's access our application from another tab, and now we can see that we are able to access, and we can see that there is home, student, teacher, and there is no teachers, like add your teacher, first teacher to see it here. Then we have student. So let's try to insert the data. So I will just write my name, and let's write the roll number name, and then let's last name, and you can see that the roll number has been updated with this, and you can also delete it. So if you, so let's see first of all from the backend side. So if I just refresh this 3500 application, so you can see that the student has data has been inserted, and the roll number is this, the name is this, and also the creation time is already registered here. And if I just delete it here, so if I just refresh from the backend side, so you can also see that the data is gone. So we can also authenticate that it's working. And if I do the same thing, so if I enter the teacher details like this, so we can see that we can see also the teacher data as well. And for teacher data, you can see, just go to the slash teacher, and you can see that data, and there is also student path as well. So if you want, you can see from here as well, but in the home section of backend, it was by default showing the data of student. So yeah, this is the thing that we have installed. And let's see, like, okay, I'm just entering few of the data. So we will just try to delete our database container, then we will see the same container again, and let's see that whether we will be able to see our existing data or not. So I will just enter few of the records again. Let's try to delete the database container. So I will just see docker ps, and I'll just remove the container using rm-f, and we can see this is the container name. And if I just check the docker ps, so we can see there is no container. So now if we just go back to our browser and refresh the application, so we can see that something went wrong. Please refresh, because it is not able to communicate with the database, so that's why it is getting, the application is getting failed. But yeah, homepage is working fine. But if you try to go to the teacher or homepage or student page, it won't work. Let's create the same container and let's see whether the data is persisting or not. So what I'll do, I'll just copy the database command that we ran earlier. So you can see that the container name is same, and let's just change the container name as well. And other than that, everything is fine, because the main thing is that we have to provide the MySQL data, because it will inject all the data from here. So if I just run this command, and let's see that the container is getting created, and let's try to And let's go to the browser and let's try to refresh whether it is able to fetch the data or not. So if you just go to the student, and now we can see that the student is getting again crashed. And if I just go to the backend, so it is saying that failed to fetch students. Now it's not working because if you remember that in our backend configuration, where in the .env file we were providing the host name as MySQL-container, but we have MySQL-container 2. The container name is this, so that's why it's not working. So what I'll do, I'll just run the another container with the same configuration, but the container name will be MySQL-container, or else you can build the Node.js application with MySQL-container 2 host name. So I'll just create one more pod, but I have to delete it because the 3306 port is already busy. So I will delete that container, and let's run the container again. I think I have to delete this one as well. And now we can see the container is getting created. And let's see, and let's go to the browser and let's try to refresh it again. And this time we can see that we are able to see the data, and if I go here, so we are also able to see the data here. So yeah, this is working. And if I just go to this teacher, same thing is working fine here. So that is it about the main thing where we are containerizing our application. So now let's move to the next part, that is reducing the size of our Docker image. So let's see how can we do that, and we will be going to see what are the things that we have to take care of. So first of all, we will start from front end, where we will try to reduce the size of the Docker image of front end. So currently I have front-end Dockerfile, which is the name of the Dockerfile is by default we have Dockerfile. But what I'll do, I'll just rename this Dockerfile to Dockerfile NBP, which is not best practices. So we can create our new Dockerfile with the best practices. So I'll create new file, which is Dockerfile. And for now, I'll just copy the content, so we will be able to understand what are the things that we have to do. And so the first thing that we have to follow is make sure you use the base image. So because if you use that image which is containing more packages than your requirement, so you should not use that image because it will increase the lot of size and it will install a lot of package that is not required. So for now, as we were using Node, which is our base image, after working with the base image, you have to make sure that after building the Node.js project or React.js project, do you need those packages or not? Like once you run the npm run build. So for that, we can do one thing, which is after building the Node.js or any backend application, we will try to use a different image where we will fetch all the build artifacts, like kind of artifacts we will fetch, and we will use that artifacts in our different image, kind of a distroless image or any nginx image we can use. So it will reduce a lot of size. The main thing is that you have to take care that your Docker file should be multi-staging to reduce the Docker size if it's possible. So we can do that. So as I was saying that this is our base image, which is Node 21 Alpine 3.17, because we are using Alpine. So again, it is lightweight image as compared to Node.js core Node Docker image. But as we will be going to create a multi-staging Docker file, so we will have to save the artifact somewhere so we can use that. So for that, you have to define it as a something that I will be going to define it as a build, because we are building this project for now, and then after creating the content or static things, whatever, we can get those content that will generated after build. So we will be going to use this. So to use this, you have to use build. So currently I've just given the name, which is as build. Then after that, work directory, it is fine because this is one of the important stuff where you are creating your own directory. Then after that, copy package.json. Then after that, you can run npm install. Now if your local folder containing any node underscore modules folder, so I would recommend you to use docker.ignore file or .docker_ignore file, where it will have the file that it won't copy these folders in the container. So as I have this in my backend folder, I will also do this for frontend, but currently we don't have any node modules folder, but it's always good to use it. Or if you want to exclude any particular file, or sensitive files you want to exclude it to add into your container, so you can use this. Then after that we are running npm install for again installing the packages, and then we are copying the rest of the things whatever there are. So like source code is very important for us, so we are doing that. Then after that we need argument, so we are getting the arguments and then injecting as an environment variable. So argument will come as an, again, like we did in the previous step when we were building the docker image for front end, so we have to provide the argument again. Then we were running npm run build. So far things are fine because it is building the code, and after building the code it will generate the static files and other codes like index.html and all those things. So once we will have those packages, what we can do, instead of using the same image, what we can do, we will create a final image. That's why we are saying it multi-staging, where we will deploy our application or build code with the help of that particular image. Now either you can use distroless or you can use nginx for that. So for now I will be going to use nginx image, and again that will also be a alpine image. So I will just add the enter, hit enter, and we might not need this in future. So for now I'll just use from nginx, and as you can see this is the version that we are using, and this is the alpine image. So again it's a nginx is also lightweight, so we are also reducing the size of the core nginx image as well. Then the next thing we have to do is that whatever we have generated the code using npm run build, or in the previous stage we did that, so we need to get it in our current container or current image, right? So what we can do, we can just use copy, and then we can give a flag which is from, so it means that it is copying the particular things from a particular container. So we have to mention that name which is build, because we have defined it as a build. So again we are not going to copy entire slash app that we were using in the work directory here. Like when we run npm run build, so we need those artifacts only. So for that it creates a build folder. So what I'll do, I will provide the location which is source location. So I need the file, all the files from the build folder, and the destination will be, as we know that nginx content used to serve in user share nginx html file. So for that I will provide the destination path which is usr share nginx html. So this is it about the build code. Now we have to copy one more thing which is nginx.configuration file for redirection and the configuration about the application, how the URLs should behave whenever you are trying to access the particular path in a particular application. So for that I've created one configuration for nginx where it is listening on port 80 and the server name is localhost. If you're configuring a particular domain, so you can mention the server name as well, where like www.amanpathak.com kind of that, and that it will get the content from this file index.html that we generated, or it can be index. Then the location, it will try to get this, and the error page for 404 it will give this. So again you can modify according to your application. I just took a sample nginx configuration because I have some issues with my application, so for that I just had to use this. So for that what we will do, we will just copy this nginx.configuration file which is present in our current directory to the place where nginx configuration we used to present. So we need to copy this nginx.configuration file in the nginx folder where configuration used to be present. So for that the location is /etc/nginx, then in the conf.d where the file name will be default.conf, because it will use this configuration as a default, so it means that we are using it. Otherwise by default nginx have some configuration, so that's why we are setting it as default.configuration. Now after this we have to expose the port so we can able to access our application. And as you know that nginx used to expose on port 80, so instead of 3000, so this is for node based application, so like for nginx I will use 80. So now in the end we will be running our nginx. So the Nginx service will be running once a container is created. So for that we will use the cmd command. The command will be nginx-g, and we are doing the daemon of. So now this is our Docker file for frontend, where we use some best practices to reduce the size of our Docker image. So before that, we need to understand that how much size for the frontend it was taking. So as we already deleted the Docker images, I already copied the size of that image. So if I just open the new tab, so you can see from here. So for frontend it was 594 MB, and for frontend it was 891 MB, and for MySQL it was 953 MB. So let's build this image and let's see that how much storage we are saving by using the multi-staging and few of the best practices to reduce the size of our Docker image. So again, I will use the same command. So for now, we did not create any backend image, but it's fine because for now we just want to check the size of our Docker image for frontend. So I'll just hit enter. So for that, I need to go to my frontend directory. My Docker is not running, so I'll just, so now it is starting fetching the image of Nginx and Node. So our image has been built successfully. So let's see the image. And now we can see the size we have reduced from, I think it was 594 MB to 49 MB. It means that around 90% of the size we have reduced, which is that we would want to do that. So it is very, it's very important to do these kind of things. I'm not saying that you will always be able to reduce the Docker size image like up to 90%, but you can try to do that, and as much as you can do, it will be good for the projects as well, and it will take less time to initialize the containers. That is one of the important thing as well. Like according to the project's requirement, you have to do these things. So I'm not going to create a container for now, because there is a dependency where we did not create the backend container or backend images. For backend we did not set up MySQL. So now we will be going to create the Dockerfile for backend, and again I will just rename this to Dockerfile NBP, and I will be going to use this. So I'll create the new Dockerfile, and then again I'll copy this the entire content. So in the previous front end, so we were trying to reduce the size of our Docker image, but in this backend we will also try to implement the best practices, that kind of security best practices as well, where the container should not be run as a root. This is one of the important thing when you try to deploy your application on Kubernetes or Docker Swarm. So let's start with the first thing, that is currently we are using Node 14 image. So earlier it was required. So this time we will be going to upgrade our Node.js version as well, because 14 is too outdated and there is no current support available in my opinion for Node 14. So for that I will use 18 version of for Node.js, and this time we will use build again that we did for front end. Then we are setting the work directory, so it is fine for that. Then we are copying the packages file for caching, and then after that we will install the dependencies using npm install. Now there is one more option if you don't want to run npm install. So there is one more thing, which is npm ci. So we can use npm ci as well. So what is the difference between npm install and npm ci? So the main difference is, as you can see, there are two files, which is package-log.json and the other is package.json. So if you run npm install command, so it will install all the packages that is mentioned in the package.json, like you can see .env express MySQL 2. So it will install that. But if you run npm ci, so it will only install whatever the things present in the package-log.json. So this way it is more faster as compared to npm install. And along with that, one more thing, that it won't include node-modules. So for installing it, it will remove that node_modules. Then after that we will use a flag which is only is equals to production. So it means that if you're trying to build the image in multiple environments, so if you mention the environment name, so according to that it will behave, like it will install the dependencies according to your environments. So if there is something related to dev, so you don't want to skip a particular packages, but in production you want to be safe when you are installing the dependencies, because it may have vulnerabilities in a particular packages. So for that, you can mention that it should be run in the production only. Then after that, we will use one more thing, which is npm cache clean, and this is help us to reduce the size of our Docker image. Yeah, so let's for that write npm cache clean, and we will use the argument is force, so it will have to run it anyhow. Then we will copy all the other files. Then after that, we will be going to make this image as a multi-staging Docker file. So for that, I will use the same image, which is node 18 -alpine. And after this, that we will be going to implement some security things, like as I was saying about run your container as a non-root user. So for that, we need to create the users so we can run our application as a particular user. So for that, first of all, we will be going to create a group, which is I will create a group name Node.js. Then in the same run, we will be going to create the user, and don't try to create users and group in a separate run, because it will create a additional layer and ultimately it will increase the size of your image. So I will create the user, which is Node.js, and we need to attach the user with Node.js group that we have created. So this is the user and group thing that we did. Then after that, we already set up the work directory. Now we have to copy all the things from the previous stage. So for that, I will use copy hyphen from is equals to build, and this time we will just copy the entire slash app, and as our work directory is also same, which is slash app, so we will copy it from source to destination, which are the same locations. Then we have to run this container. So for that, the container should run as a non-root user. So for that, we have created the Node.js user. So for that, we will provide the name is Node.js. Then we will expose our application, which is I will be going to expose it on our 3500 port. So this is a thing that we did. Now if I just keep things more good, so I will just make this more understandable. And now it's looking like a multi-staging file. Now we will build the image for backend. So what I'll do, I'll just get the command to building the Docker image for backend. So now we can see that our backend image has been built successfully. Let's see the size of this image. So the image size is now 152 MB, and earlier it was 890 MB. So again, like I think 70 to 80% size has been reduced. That is again one of the good thing. So as I've explained you how to reduce the size of backend and front-end Docker image. So there is one task for you, that how to reduce the size of your Docker file for database, or is it possible or not, and if it's possible, then how the file should be look like. So if you know that, so you can drop in that comment sections. This is all about it, and let's try to just build the application once more, so we will be able to see that are we able to run the container for our application or not. So I will just simply create the container for our MySQL. So again, for that, first of all, we will build the image. Then we will run the container for MySQL, and it should create the container. Yes, we can see that. Let's run the backend container, and also backend container is getting issues. Let's see the issues. let's run the Docker container for our backend image. So we will do this. So let's see the container. So yes, we can see the container, and let's check the logs of our backend container. So yes, the server is running and it is connected to our MySQL container as well. Now the next thing that we have to run is our frontend application. So I will run the Docker container. So this time we will use the port 80, and we just have to use the same port. And if I just check the container, so yeah, we are able to see the front-end container as well. Let's just check the logs. So yes, we can see. Now let's check the application. So this time we will be access our application on localhost because it is running on port 80, and we can see that our application is accessible. Let's check whether it is working with the database. We can see the data is still existing as we have deleted our Docker image and Docker container, because the reason that we have mounted our volumes on our local machine. So that's why. So let's just add new records, so whether the database is working fine or not, let's check. So I will just add the we can see it is working, and if I try to delete the records, it is also working. And yes, so this is working fine. So this is it for the Dockerfile concept, and I hope you'll also learn that how to follow the best practices and what are the best practices that we can follow while creating our Docker image. Because if you want to learn Kubernetes where you have to deploy the applications, it's very important to work on Docker, where you will have to learn that how to reduce the size of your Docker image and make sure to follow the best practices. Now the Dockerfile thing has been completed, and as we have seen that to deploy a 3-tier application, we need to run multiple steps. Like we have to build all 3 images using the docker build command. Then we have to run our containers using the docker run commands. But the point is that, like, as we have to run 6 to 7 commands, and sometimes it's not good to do that, because I want to make it more automated, where we just need to run one command, and with the help of that we will be able to deploy all 3 applications, which will create image, and also it will run our application by running the containers. For that we have one thing, which is Docker Compose. So Docker Compose will help us to build all the images, and it will run the containers as well. So once we will run Docker Compose up command, it will build all the images and run all the containers of all the images. So let's do that. And first of all, the Docker Compose file should be in your root. So let's create the Docker Compose file. So the file should be in the root folder, and the name of the Docker Compose file should be docker-compose. As soon as you write the name with extension, you can see there is one ping docker icon, so it means that it is correct. Now let's start writing our Docker Compose file. In the Docker Compose file, we used to have versions, but in the latest Docker Compose version, you did not need to specify the version, and if you don't specify the version, it's fine. So we can directly jump on the services section, where we will define the services and the specifications of that. So first of all, the main thing that we will have to do is services, and we need to create the services. As we are following the bottom to top approach, we will create the database services. We will give the name to our service is db. Then we will start giving the specification. So the container name we will have to specify. So for that we will provide the container name is MySQL container. Now the next thing that we have to specify, that we can also specify the image. So I will specify the image here, and I will just take the image of the from the database Dockerfile itself. So this is the image. Then the next thing is policy, which is related to restart policy. So you have seen in the Kubernetes as well, so it is kind of that. So I'll just write the restart policy as always. Then we have to set the environment variables. So for that I will just write environment. After that, as we have set up the environment variables through the Docker file as well, so we have to do the same thing here. So if you have some other variables, these environment variables will be overridden into the Docker file. So I will just get the root password environment variable, and for now I will just keep it same. Then we will have database name as well. Database name is school. Then the next thing that we have to specify, which is volume section. So in the volume section we have the volume data again that we have already provided, which is at the location of where lib is MySQL. Then we have to specify the port. So the application will be running on port 3306. We will have to specify that thing as well. So this is about the ports. Then after that we will configure health check. So with this health check we will be able to understand that our container is running and working up correctly. So I will provide the health check keys value. So this here we will write the test, and in the test it will run a command, and in that it will try to ping the, as you can see in this, so it will run the command as a cmd and it will try to ping the localhost, and the password of this is that we have already mentioned. Then if the test is failing, so we can specify the intervals, like the health check thresholds, how many times it should fail. So for that we will specify interval, which is I will keep 10 seconds. So after each 10 seconds it will try to ping if it is failing. Then so if there is any timeout issue, so we can also mention that thing. So for that I will keep timeout second is 5 seconds. Then retry policy is always must when you are trying to do health checks. So I will keep the retries as 5. So now this is all about the things that we have configured for database. Now the next thing that we have to do is for our backend. So make sure the indentation should be correct. So this is our backend, and almost things would be similar in most of the case. So first of all we will provide the container name, which is we will keep backend. Then we have to provide the context, where as we were using our multi-staging, so for that we will use build, and in that we will have to provide the context, which is our backend. Then we will provide the image name, so I will keep the image name as backend image. Then again I will provide the restart policy, so for that I will keep the restart policy as always. So the port will be same that we were using, which is 3500. So now the next thing that we have to define our environment variables. So environment variables for our, so as you can see that we have already provided the .env environment variables in our .env file, but if we do it from here, so we don't need our .env file, and always try to use docker ignore if you don't want to inject .env in your containers. But right now I'm not doing it, and we will be going to provide the environment variables from here. So I will just write environment. So first thing that we have to provide is our host. So in Docker Compose, the host is our DB, because ultimately it's deploying this, and this time we don't need to provide MySQL container. So for that I will provide the host is DB. Then we have to provide the user. So user is, we are using root. Then we have the database. So the database is school. And in the end we have to provide the password. So I will provide the password here. Now you can also specify the meta arguments like depends on. So this backend service should run after only DB service. So for that we will add one more thing, which is depends on. So in the depends on we will provide the service. So in the depends on we will specify our DB service, and there is one more condition that we will add, that the DB should be healthy, then only it should create the backend. Otherwise there is no benefit to create the backend if your database is not healthy. So for that I will just add the condition, which is condition colon service healthy, because we already specify the health check as well. So this is annotate to the health check. So this is all about the backend. Now let's do the last. So I will provide the service name as frontend. Then we will provide our container name. So I will write the container name as, so in the build we will have to provide the location of our frontend Docker file. In the context I will provide the location. So the location is frontend slash, and same thing we did in the backend as well. Then as we were building our image using the docker build commands, we were also providing our argument, which is we were providing the host name to connect with the backend. So we will add arguments. So the argument will be this, and then we will provide the key, and after key we will provide the container host name. So currently our application is running on 3500 port, and it is working with localhost as well. And then we will have to provide the image name, and this time the image name would be, I will keep that it will be a front-end image. Then the restart policy we will keep always. The ports will be 80. The ports we will expose the application on port 80. And then we will add the depends on condition. So the depends on condition we will keep it as backend, and in the backend we need to have one condition, which is the service should be started. So for that I will add service is started, and in the end we have to specify one thing, which is our volume. So as we are deploying our application using Docker Compose, so this will create a new volume, and for that we will provide the volumes, and the volume name should be MySQL-data. So this is all about the Docker Compose file. And one thing I have to tell you is, when we were deploying our application using Dockerfile, in the very first step we created Docker network, 3-tier network. So this time we don't have to create it, because Docker Compose will manage the network itself, because it is creating all these containers within that network only, as we have all three applications in one Docker Compose file. So that's why we don't need to do anything. So now what we will do, we will just run Docker Compose command, and this will fetch all the images, and this will create all the containers, and the application will be up and running. We don't have to do anything. So first of all, let's see whether the images are present or not, and also let's see the containers. So first of all, let's see the images. So as we can see, there are no images. So let's check the containers as well. So there are no containers. So let's run the Docker Compose command to deploy our applications, including building the images. So for that I will run command docker compose -up -build, and now you can see that it is pulling the DB, and after that it will start pulling. Then also we can see that it will also we can see it is start pulling the backend thing, and we can also see that all the four things has been created. Okay, so we got an error, and as we can see that the invalid restart policy. So the point is that the A is capital and it should be always. So let's first again see is there any images or containers. So yes, the images are present, and if I see containers, so there is no container. So again I will remove all the images. So I will run the command, and let's deploy it again. In every restart policy I just kept it A capital, so that's why the error is coming again and again. So what I'll do, I'll just move all those things again, and yes, we can see there should not be any container running. So let's deploy it again, and I hope this time we won't get any error. And this time we can see that it is also building the database container, but the issue is that the container is unhealthy. Let's see the error, like let's see the issue, what exactly the issue is. So the issue is related to image, so let's use the specific image instead of providing the latest. So I will keep my Docker image as 8.0.40 because there is some incompatibility with volumes and the previous version of Docker image. So currently it's trying to fetch 9 version of MySQL, but our application and volumes are attached with the version 8.0.40. So let's try to do that again. And again, we will clean up the things. So let's build it again. And we can see the connection with MySQL has been configured. Also, the backend service is up and running and front end is also running. So let's try to access our application. So if I just hit refresh, so it should start working. And now we can see that there is no student teacher data because it created a new volume. So I will do that. I will show you that thing as well. But before, let's try to add some details, whether we can see whether the database and backend is working fine or not. So I'll just add random data. So yes, we can see that. So let's go to the volume section and let's check whether it's created new volume or it is using the existing volume, because if it's using the existing volume, it means that there is some issues and the data is not. If you want to run this in the detach mode or in background, so you can just use -d command with docker compose --- build. So you can do that, but for now I will just open one more terminal to check the volume. So for that I will run the command docker volumes ls, and we can see that the volume, and you can see that earlier we were using MySQL-data volume, which has a data, and after creating this using our Docker Compose, it created new volume which is MySQL-data. So that's the reason it didn't work, and this is expected. Also, if I show you the network, so you will see that there would be a new network created, and we can see that it created new network which is Dockerfile project default. And earlier we were using 3-tier network, and let's see the images and containers as well. So first of all, I'll show you the images. So we can see that there is a backend image which has 152 MB, then we have front end which has 49 MB, and then we have MySQL which is 608 MB. So as you can see that earlier it was 953 MB, and because of this, when we have tried to deploy using Docker Compose, it is 608 MB. And maybe it might be the reason because of the version, because earlier if you see that the latest version has 953 MB. So this is not like Docker Compose into anything, it's just that we changed the version, that's why it reduced the size of our MySQL Docker image. And if I just check the Docker containers, so we can see that all the containers are up and running, and also it is healthy, it is showing us the status which is healthy. So that's it about this video, and I hope you learned something, because when you everyone wants to learn Kubernetes, everyone wants to know about Kubernetes, but it's always be a must thing that before jumping on the Kubernetes, you need to understand what is Docker, because the reason is that Kubernetes is used to orchestrate the containers. If you don't know anything about containers, so there is no meaning to orchestrate the containers, right? So it's always good to deep dive in Docker before jumping on Kubernetes, because you need to understand that why should you use Kubernetes. Can't Docker help us to orchestrate those containers? There should be something so we can use to orchestrate the containers using Docker tools only. So there is one thing for that is Docker Swarm. So, but why Kubernetes is trending in today's time? So there are a lot of things, but it's always good to, you should learn things one by one. Instead of learning directly Kubernetes, you should learn Docker first. So this is the thing that we have covered about this. And as I've told you that this is a beginner friendly, maybe if you're intermediate DevOps engineer and you did not work enough on Docker Compose or any of the thing that we have covered today, so it will help you, and it will help you in your day-to-day things, so you can try to innovate something if you want to do something, right? That's it for this video, and I'll see you in the next one. Have a good day.